Welcome to the real life possibilities of time travel with your host, Mr. Henry, the Science Geek. I want to start by asking you to take a journey into time and space, beyond what you thought was possible, into the world of science fiction, into the realm of quantum physics. When we think about time travel, most people, think of movies, they think of entertainment. So I want to pause right now and ask you, where have you heard or seen time travel come up? Do you think it's possible? Before I even get into the video, do you think maybe this is a big Friday joke? How might it be possible? And if we can time travel, should we? Most people think of science fiction. This was a classic book and movie, The Time Machine. Then we moved on to the 1980s, Back to the Future, with Marty McFly. And more modernly, we get Doctor Who. And in everything from Star Trek to Star Wars, there's been elements of time travel and time being bent by different laws of the universe. So is this possible? Einstein thought that based off his equations of the math and the universe, time travel was possible. But it would be incredibly difficult. And we're going to explain why today. Before we even get into time travel, we need to understand what we're traveling through. What I want you to think about right now is what makes a clock track time. I want you to consider, potentially for the first time, what makes a minute a minute. Why is it 60 seconds? If I said, hey, what is 1 second? There's really not a good answer to say, well, it's a amount of time that we made up. And when you start to kind of realize that clocks, minutes, hours, a lot of that is something that we kind of just made up to keep track of time. What I want you to think about instead is everything that's ever happened exists on a fabric, a timeline. In your head, if you want to imagine, it's a massive timeline that spreads out in all directions like a blanket. It goes on way off past the horizon to the left, to the right, behind you, in front of you. And everything that has ever happened exists on this blanket. But we can only move in one direction. So once we take a step forward on that blanket, everything that's behind us in the past stays there. And on this blanket, we also have dimensions. We have space, right? We have flat things, squares, tall things, 3 dimensions. In science, we call this the 3+1 dimension. 3 being length, width, and height. So that's when you go from like a line to a square to an entire cube. But the +1 is time. Another way to think about this, I usually tell students, I'm holding, for example, a cup of coffee in my hand. I know that this cup of coffee takes up space, right? It's in my hand. I can hold it, it has weight, it has mass, it has volume. But this coffee cup exists at a specific time. It exists at 10:40 a.m. on Friday. And that space has a point in time that it exists. This may seem confusing because we never really think about what is time. We just kind of accept it. But if we're going to understand what time travel could be, we need to understand that time is not based off a clock. Let's say time travel is possible. Einstein says the math checks out. What I want to ask you is, do you think we can travel forward into time, into the future? Do you think I could build my perfect time machine, go visit the dinosaurs, and go backwards? Or do you think we could just do all of it? You could press a spaceship, go forwards, press a spaceship, go backwards. So I want you to right now on Edpuzzle write down, do you think you can go forward? Do you think you can go backwards? Do you think you can go both forward into time and backwards into time? Are you convinced that this is, again, an elaborate Mr. B classic joke? Alrighty, right now we're gonna move on to what I like to call story time. This is the grandfather paradox. Sounds kind of scary, and it is. The grandfather paradox is a thought experiment, so this isn't true, this is just what scientists use as an example of why something can't exist. I want you to imagine that there's a grandfather somewhere. He's alive, gets married, has a kid. That kid grows up, becomes a dad, has another child. So if you're tracking this timeline, this is the man that's born. The man's like, you know what, I'm a brilliant scientist. I saw Mr. B's lecture, and you know what, I'm going to build a time machine. Alright, so he travels back in time, and he's like, you know what, I never really got to meet my grandpa. So let me go back in time, and, let's try to meet him. And for some odd reason, the man accidentally kills his grandfather. Oh my gosh. Now, if Grandpa died, then the dad was never born, and then that means the man who invented the time machine never was born. Oh, we're clear then. If he was never born, then how did he invent the time machine? Okay, let's take that. So he never was born. He never built a time machine. If he never built a time machine, how the heck did the grandfather die? And if he never died, then the man's alive. And you see how this goes back and forth? And again, look at this diagram for a little longer than I'm talking over, because it is super confusing. And that's by design. So if the man lives, then he kills his grandfather. And if he kills his grandfather, then he can't exist. And if he can't exist, then his grandfather is alive, and you see that it goes back and forth. And both cannot be true. Because of this paradox and a few others, that if one thing is true, then the other thing cannot be true, and it flip-flops every time you go through the different pathways, scientists say travel into the past is probably not possible. So there's no dinosaurs, there's no going back to Egypt, there's no going back to the Aztecs. I'm sorry. So, let's go to the big idea of today. The big idea that Einstein proved is nothing, and I mean nothing, can be faster than the speed of light. He said that's a fundamental law of the universe. Light moves super, super fast, and nothing can be faster than that. And then he realized, if that is true, if something, let's say we built the best spaceship, the best thing in the history of the world, and it's traveling at 99% of the speed of light, then it could potentially break the speed of light. So, the universe has a safety valve. It has protection. Because if something travels past the speed of light, something might break in the laws of physics. So, time begins to slow down to make up for this difference. Now, this seems kind of crazy. Like, how can time slow? Like, why would my clock go slower? We're going to explore that. I want you to imagine that you're on a rocket ship, and you're going to go really, really fast, 99.9% the speed of light. And remember, when we said time is going to slow down when you go that fast. I want you to go, just go somewhere for a week, fly around the universe with your super speed rocket ship, okay? Alright, good luck. Have a good one, astronaut. You come back in a week, and it's 100 years into the future on our planet, but you've only aged one whole week. You get off your spaceship and you're like, my goodness, what is going on? Mind blown. Time travel, thus, has been proven. But wait, how does this even work? Let's take a look. Einstein called this special relativity. We don't have to get too far into it. You'll learn about it more in high school and later in college. But let's look at the simulation. This is what I like to call the light clock. Jack's got a car, Joe's got a car. And this is what their clocks say. Each of them have a different clock, and it's like a special, amazing clock that's super accurate. And I say, alright, Jack and Joe, I want you guys to travel the same speed. Rocket ships go. We press play. We let it go for a little while, and after 6 seconds, Their clocks, exactly the same. Alright, so I say, Jack, we're gonna keep the rocket ship moving at the same speed as it was. I like, 6 seconds, that's a pretty good time. Now, Jill, I want you to go, let's say, half the speed of light. For those watching at home, c is the speed of light, so 0.5 c is half the speed of light. Let's see what happens. Alright, Jill, get in your rocket ship. Jack, you get in yours. Something's interesting is happening here. So Jack's clock read 9 seconds and Joe's read 7.94. So Joe's clock ran a lot slower, like a whole second. Let's redo this. I think maybe that was a mistake. Maybe this just isn't. Let's just have Joe go the speed of light and see what happens. So Joe's off to a fast start. Jack already released, he's trying to get the balloon up to the ceiling. It's bouncing back now. And Joe, feel free to get started anytime now. It's been like 8 seconds. You can you can get moving. Alright, jokes aside, when Joe's moving at the speed of light, her clock hasn't even registered 0.01 seconds, but Jack has already gone 10 seconds. You can let this go on for a lot longer, but it's gonna take quite a while for Joe's clock to even read 1 second, because she's going so fast, right at the speed of light, that it's gonna take a minute or two. And this is the crazy thing about time and speed. When you get really close to the speed of light, even 80% of the speed of light, there's huge differences. That concludes our proof of time travel. In summary, if you get in a rocket ship and go really, really near the speed of light, the laws of the universe say you cannot go any faster, so we have to slow down the time. And then if you then slow down, go back home, and the home has stayed at the same speed it's always been, but you've been going the speed of light, you're fine. Often, you're going to be way into the future, but you've only spent a week or two on your rocket ship. I want to end with a really cool note. This is a PowerPoint and presentation I've given all across the country that started with my 8th grade final project. This presentation about time travel I've given to high school students 5-10 times, and I've built it up since 8th grade as one of my favorite lessons to teach students. Things you do in 8th grade matter. Things that can change your life happen here. And I'm proud to share this with you, and I hope you found it fascinating. Henrik the Science Geek, signing off.